Okay, today we are going to start talking about independent and dependent events and then how we find the probability of independent events. Then the next time we'll talk about how we find the probability of dependent events. So two events, so we can see here the definition, two events are independent events when the occurrence of one event does not affect the occurrence of another. So if you are rolling a die and then you draw a card from a deck, those things have nothing to do with each other. Those would be independent. Something is dependent if you have a jar of marbles and you take out a marble and then you don't put it back in, and then you take out a second marble. Your second marble is going to be dependent on the marble that you picked out from the first time because there's less marbles in this jar now, okay? That's the difference between independent and dependent events. Today we're mostly just going to be focusing on finding the probability of independent events. So, two events, A and B, are independent events if and only if the probability that both events occur is the product of the probability of the events. So, the probability of event A and event B of the whole thing happening is equal to the probability of event A times the probability of event B. So really, like, the important thing is this thing here to know what to do and making sure you understand the difference between independent and dependent events. So we're going to do a few examples. So example one, determining whether events are independent. So a student taking a quiz randomly guesses the questions to 4 true or false questions. Use the sample space to determine whether guessing question 1 correctly and guessing question 2 correctly are independent events. So a couple of things. The first thing is we should be able to tell just by reading this if it's independent or dependent. If you get question 1 right, that does not have any impact on whether you're going to get question 2 right. So these are independent, and we can see that right away, but we are going to just kind of prove to ourselves that it's independent. So the way we're going to do that is remember from the last page that the probability of A and B must be equal to the probability of A times the probability of B. So if we kind of look at this right here, getting question 1 right, that's the probability of A. And getting question 2 right is the probability of B. And then getting both of them right is A and B. So what we're going to do is first figure out what's the probability of A, and then what's the probability of B, and then what's the probability of A and B, and I actually am going to make that another color. And then we will see if we multiply these together, would we get this one? So the probability of getting A and B right, so that means this one and this one, means that you get question 1 right and you get question 2 right. So over here is the sample space. The first one, the first choice or outcome would be getting none of them right. And then the next one would be having, if you get 1 right, you could get the first one right, the second one right, the third right, or the fourth. Here, 2 of them, you get 2 wrong, 2 right, 1 wrong, 1 right, etc. So this is the sample space. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 options. So since there's 16 possible outcomes, I'm going to put 16 at the bottom. And so now what's the probability that we get question 1 correct and question 2 correct? So question 1, nope, none here. This one doesn't work. This one, nope, 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 nope. Okay, so question 1 and 2, that's that one. Question 1 and 2, that is that one, and that one, and that one. So there's 4 possibilities for getting question 1 right and question 2 right. So we're going to have 4 over 16, which does reduce to 1/4. All right, so now we're going to talk about what about if we had the probability of A. So the probability of A is getting question 1 correct. So we still only have, I'm just going to put there for myself, we still only have 16 options. And now what's the probability that we get question 1 correct? not here. Here, question 1 is correct. Here, question 1 is correct. 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 So 1, 2, 3, 4, 5, 6, 7, 8. So 8 out of 16, which is the same thing as 1 over 2. And now we're going to do the same thing with B. So for the probability of B, that is getting question 2 correct. So question 2. So 1, 2, 3, 4, 5, 6, 7, 8. So we get 8 out of 16. 8 out of 16 is really 1/2. So here, does 1/4 equal 1/2 times 1/2? Yes, it is. So these events must be independent if they're following this rule. So they are definitely independent of each other. So we should be able to determine if they're independent just by reading this, but this is one way to just kind of figure out, mathematically and prove to ourselves, yes, they are independent. We're going to do one more example, and then we're going to find the probability of some independent events. Here's our next one. A group of 4 students includes 1 boy and 3 girls. The teacher randomly selects one student to be the speaker and a different student to be the recorder. Use a sample space to determine whether randomly selecting a girl first and then randomly selecting a girl second are independent events. So the two things are here. First, randomly selecting a girl first, and then the second person that you're going to pick is also a girl, selecting a girl. Okay, are those independent? So if you only have 4 students and you pick one girl and that girl has a task and you need to pick someone else, you now have changed the odds because you've removed one of the girls. So these are not independent events, which you probably can tell just by reading it, but we are going to kind of prove it to ourselves. So we should remember that the rule for how this worked was independent events will follow the rule that the probability, ooh, that P is ugly, of A and, oh, all right, hold on one second. Let me try to fix this right here. Okay, so let's try this again. That the probability of A and B is going to be equal to the probability of A times the probability of B. So I've kind of assigned what the probability of A is and what the probability of B is. So this blue one here is going to be A. Oops, my color didn't change. My life is in shambles. So the blue one here is going to be A, and then our green one is going to be B. So first, let's figure out what's the probability of A and B. So basically, using this sample size here, what is the probability of selecting 2 girls? One girl first and then another girl second. So we can first look at, we have 1, 2, 3, 4, 5, 6, 7, 8, 10, 11, 12 choices total. And the probability of first a girl and then a second girl is 1, 2, 3, 4, 5, 6. So we have 6 out of 12. And now we want to see if that's equal to the probability of A times the probability of B. So the probability of A is going to be blue. So the probability of A is that there's a girl first. So it doesn't matter who's after that, just that there is a girl first. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9 out of 12. Which I should have done this one here. This one reduces to a half. This reduces to 3 over 4. And then let's do the probability of B. So the probability of B is just that the second one is a girl. So no, 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 but 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have times 9 over 12, which reduces to 3 over 4. And so what would need to happen for these to be independent is that 1/2 would need to equal 3/4 times 3/4. 1/2 does not equal 3 times 3 is 9 over 4 times 4 is 16. So these are not equal to each other, which means that these are not independent. So they are dependent. Dependent. Hope I spelled that right. Okay, so again, you can tell just by looking at it, but it is important that you can also figure it out by doing the math out. Okay, our last one is actually finding the probability of an independent event. So it says, as part of a board game, you need to spin the spinner, which is divided into equal parts. Find the probability that you get a 5 on your first spin and a number greater than 3 on your second spin. So when we have this and situation, two events that are definitely independent of each other, these rolls don't, the spins don't have anything to do with each other, then we're going to find the probability of the first one and then multiply it by the probability of the second one. Probability of the first one, you get a 5. There's 8 options, there's 1 5, so it'll be 1 over 8 times the probability of the second one, a number greater than 3. So that will be 4, 5, 6, 7, or 8. So we have 1, 2, 3, 4, 5 options out of 8. So times 5 over 8. So we will get 5 over 64. So if you do 5 divided by 64, you would get 0.078125. So this is the probability. You can keep it as a fraction or a decimal. However, on your Schoology homework assignment, I'm going to change this into a percentage. So if I wanted to change this into a percent, I'd multiply it by 100 or move this decimal place over 1, 2, and the percent chance of that happening, I'm going to write is 7.8%. Or on Schoology, I think I have to round to the nearest whole number, which would be 8%. So please make sure, like, yes, this is the probability. It's fine to write that. But on Schoology, I did turn it into a percentage when there are fill in the blank questions. So please make sure you're mindful of that. If you have any questions about identifying whether events are independent or dependent or finding the probability of independent events, please make sure that you email me. Okay.